Hi everyone, I'm Grace.
I'm Derek.
And I'm Kevin.
We're going to present on our vehicle insurance sales prediction data set, and this is our work we have so far. And Derek is going to first talk about the EDA process.
So first, I'm going to talk about EDA. The first step is to check null values and duplicates in the dataset and potentially clean the dataset. But it turned out to be a really clean dataset with no null value and no duplicates. And I also drew some distribution plots on the numerical variables. For example, the ID, age, policy sales channel, and vintage. And they turn out to be evenly distributed. For the variable vehicle age, because it's categorical, I used histogram. And there's one suspicious variable called the annual premium with a lot of outlier values. So we decided to normalize this variable.
So next, moving on to feature pre-processing, we want to reduce some features. So by finding the quasi-constant features and looking at the coefficient matrix heat map, we reduced the number of features from 11 to 8. We dropped ID and vintage since the absolute value of the correlation coefficient is less than 0.01. That's the relationship between the variable itself and the response variable. We also found that the driving license is a quasi-constant feature, which means that it has the same values for a very large subset of the outputs. Some other things we've done in this step is that we did label encoding for some columns. For example, gender, vehicle age, and vehicle damage contain text values such as yes, no, male, female. So we converted the values to integers such as 0 and 1. We also changed all variable types to integers and normalized feature variables. And next, moving on to the models we've implemented so far. So for the decision tree, I used the holdout method to split the test and train data. We used grid search CV to tune parameters, and the best parameter we found is Gini for criterion, and then 7 for the depth of the tree, and then random for the splitter. And the testing and training accuracy are pretty close. It's about 0.87.
With Canon classifier, so we use the same, use the holdout to split the training and testing data set, and also use the five-fold cross validation to run various k values. And one thing we realize is that as the k increases, the misclassification error drops. But this is just one component of the k classifier, because as you can see, it has like a lower accuracy than other models. And we're thinking of just using a search grid to actually find the best other parameters that we can tune to maybe bump up the accuracy.
So last, I'm going to talk about logistic regression part. I also use holdout method to split the training and test data set. And because of the size of data, I chose to use tenfold cross validation to access the accuracy on the training data set. So these are the 10 accuracy score that we got from the 10 cross validations. And also after applying the model to the test data set, we got an accuracy of 0.8727.
Going forward, one of the steps that we want to implement is normalize certain features instead of all features. This is because like most of the models that we have so far are based on the actual data, raw data without like the processing applied. And we're also thinking of running some model assessment methods like F1 to kind of increases the precision and the better classification. And also for with AUC, and then we can use those metrics to measure how like the performance of models. And we're also thinking of running other models to also see maybe if we can get a higher classification prediction. So those include boosting random forest.
Thank you.
Thank you.